Good morning, everyone. I'm John Newquist, and we're going to do excavation and trenching. We are going to record this session for a YouTube video. This is going to be used as a training method for one of the 50 modules in a lot of these tests. The questions that I give on the knowledge check are not the actual questions. I take the concept and I rewrite the questions, so these are not the word-for-word actual questions. The learning outcomes. The trenching and excavation side is covered in the CHST, ASP, SMS, and STSC. An excavation is a man-made cavity in the earth. It can be as wide as in the middle picture or a short, narrow trench. It doesn't have to be a certain depth. A trench is always no more than 15 feet. That's just a subtle difference between excavation and trench. Many methods to protect the person. You have to have cave-in protection at 5 feet. So if you're only 3 feet deep, there's no dirt at the edge, you would make an assessment, but otherwise there was not a cave-in hazard probably. You can use benching, which is in the OSHA standards. You can go up maybe 3 feet, back 3 feet, and so on. They give you criteria, and then that's going to be beyond this, level of class. One of the things that OSHA pushed in 2018, they want to see fall protection when there's a hazard of falling in. That rule starts at 6 feet. We're looking for guardrails. So all the manufacturers of these protective systems, they usually make a guardrail system that they can use to prevent somebody to go through. We want our ladders for access to be extending 3 feet above the trench box. And the competent person is somebody who has the ability to recognize hazards and take action. And they have to know how to do soil classification, the protective systems, the OSHA requirements. Usually a competent person is tested. They're given a class and they're going to be tested on their knowledge on it. I teach a typical class for a competent person at about 6 hours. In this landfill, we are only about 4 feet high. There's no dirt at the edge, but they have to make an assessment of what kind of gases could come up. And hydrogen sulfide and methane are very common gases. They would wear a meter if they were going to be in this trench just to spot or detect anything that might be easing out of the ground. But what's missing is a ladder. We would want a ladder in these trenches. That ladder rule starts at 4 feet. So one of their knowledge checks, we'll just go over a few of these during the class. An excavation is performed in an old landfill. What should the air be tested for? Carbon dioxide and methylene chloride, carbon dioxide and sulfur dioxide, hydrogen sulfide and methane, dimethyl bromide, and ammonia. Excellent job. The answer is hydrogen sulfide and methane. People would just type the answer in chat here. Again, a cubic foot of soil is only going to weigh about 100 pounds, give or take about 20 pounds or so. A cubic meter of soil is going to weigh quite a bit. 1,200 to 1,700 kilograms, or about 3,000 pounds, give or take about 400 pounds. It's a lot of weight. When it collapses on top of you, you have all these weight of hundreds of kilograms, hundreds of pounds on you. You're not going to be able to breathe out. Your diaphragm sucks in the air, and it's going to be hard for it to push out, and that's how you get killed. You get asphyxiated because you can't breathe. Daily inspection excavation, the adjacent area and protective system shall be made by who? For evidence of a situation that could result in possible cave-ins, indication of failures of protective systems, hazardous atmospheres, or other hazardous conditions. A, the competent person. B, the general contractor. C, the qualified person. D, the registered professional engineer. Excellent. A is the answer. People ask, what is a qualified person? Someone with extensive knowledge and experience that knows how to do the math, as I call it. They're able to go in and qualify and say, if we wanted to freeze the soil, our system here can work on a 10-foot deep trench, and we're going to put this method, and it'll be a protective system. Registered professional engineer is needed at 20 feet. Trenches and all the excavation collapses are different ways. It can slide in, it can topple in. If you got an opening, the soil wants to heave or come up, especially in change of weather. If you got water, it makes the soil weaker, so water is automatically going to be soil type C. It wants to literally dissolve the soil and push it up and make it. And these areas could be type A soil, but it's just going to crack and then come right in. So the competent person is going to inspect the excavation every day before people get into it, and they're going to look for the hazards that could happen. This is all sand. Sand is, by definition, type C soil. No cohesive strength, no compressive strength, less than 0.5 tons per square foot. Going to be sloped at about a 34-degree angle. This is sloped at about a 45-degree angle, so it's not in compliance. Where's our ladder? We need a ladder when the trench is over 4 feet deep. You have to have 25 feet to get a ladder. That's missing. Then we got the dirt, which they call spoil, excavated earth, right at this edge. That's not good. And that's, where the person's going to get the person out of the trench, and let's discuss why this is not safe. You can use shoring, sloping, benching, or shielding. A shoring system is designed by an engineer. They'll give you tabulated data. Some people call it the owner's manual, but it's called tabulated data in OSHA. It's going to tell you how far to space it, how far it's got to be from the top, how far it's got to be from the bottom. Different types of shoring systems. Some are 4 feet, some are 10 feet. You can buy a lot of different combinations. 35 years of good, safe practice. Sloping, this is a soil chart for C. You're going to slope it at a 1.5 to 1. So if it's 10 feet, you go up vertically, it's got to be cut back 15. All this excavated earth here is going to be taken out. I like the trench boxes or trench shields. They're designed by engineers. They can take a lot of weight. I've never seen a trench shield buckle in over 30 years. So the shoring system can be a lot of different ones. They'll tell you how far you got to space it, the size of the cylinder. Everything's going to be on a tabulated data. When we're over 20 feet, you got to have some protective systems. In this case, it could be wood or it could be metal. You could take sheet metal and put the wood in here, hold these by certain size timbers. They actually have engineering charts in OSHA that you could follow if you're in these cases. The engineers, if it's over 20 feet, they're going to have to use some calculations and determine what would be necessary. But one of the things that Zurich is doing, because they write up a lot of worker comp, is they're doing an activity hazard analysis, because you're out there looking at the trench and excavation hazard and you can miss the other things. Like this stair rail does not have a mid rail. You need a top and rail and a mid rail. This platform area doesn't have a rail. And the lower stair doesn't have anything at all. So these are things that you have to look at, as well as the cave-in hazard. And sloping is going to be at 34 degrees for type C. It's 1.5 to 1. B soil is 45 degrees. This is 45 degrees here. 3/4 to 1 or 53 degrees is going to be A soil. The other 4 soil type, believe it or not, is called stable rock. That means you dig it. In our area, we have limestone rock. It'll stand up for years. I have excavations that have been dug 40 years ago and they're still standing up vertically. They have different soil types. Cohesive soil is the most stable. It has clay in it, compressive strength of 1.5 tons per square foot. B soil is silt, loam, angular gravel, 0.5 to 1.5 tons per square foot. Sandy gravel, less than 0.5 tons per square foot. It's mostly sand is what I run into. So you can buy a pocket penetrometer for $100. It'll read how many tons per square foot. I would just take an example in the practice session. I used a cantaloupe. I got 1.2 tons per square foot. That's a method to do. You might want to take 3 samples of the different soils as it's being excavated, and you would measure it. Now, obviously, it won't be cantaloupe. It'll be dirt. But if I measure 1.2 tons per square foot, that's going to fall in the B range. So they've asked questions such as, I have soil that's mostly silt and silty loam. I measure 1.2 tons per square foot. What soil type is it? And it would be B soil. Shoring prevents cave-in, and the idea is that you're going to make sure it's pushing against the soil. It can hold the weight that the soil wants to collapse into it. Again, all these systems are really based on engineering diagrams. This one, you can see the shoring is very close together. That's because maybe the manufacturer will say it. You can use this in all types of soil, but you got to follow the criteria. In sandy soil, this is going to have sheeting behind it. Here we got wood shoring. Follow the tables in OSHA or have an engineer make one for you, but wood's so expensive. You know, if you want to get a 6x6 piece of lumber here for your wales, that's what they call the horizontal members, wales, or it looks like it's wale, but it's wales. This is going to cost hundreds of dollars. You know, that's not something that's very easy. Alexa, stop. Part of the shielding is that the boxes, they're making them smaller and stronger, and it's nice because a lot of these will fit on the back of a pickup truck. You don't need to have a semi-driver with a CDL license. Here we got our ladder 3 feet above the landing. We're getting to do the work, and that protective system is going to protect that worker. Underground utilities. You got to use a one call. In our area, it's 811, or we call it Julie. You got a yellow line, it's gas. You got to hand dig within 18 inches of this line to show this gas line right here is there. And you know, you may be putting in a water line or a sewer line next to this line, and that's part of the whole thing. You have to think about, where's it going to go, how deep is it, is our line going to interfere, are there utilities crossing? So they have to come in, they use locating equipment, and they mark these lines. Only on the tests like the CHT, they may ask you what red or yellow is. Red is electrical, yellow is gas. There are other colors recognized by the agencies, but they haven't asked about that. So the safety professional evaluating an excavation plan for an office building. The building owner wants to dig 30 feet. Who must design the protective system? These are what I call scenario questions. As I'm watching the BCSP give more and more questions, they're going away from what is the number or what is the requirement to a scenario that you are in. So who has to design it? The protective system, the building owner, general contractor, or registered professional engineer. Very good. Registered professional engineer. Utility companies by OSHA must be called 24 hours prior to excavation. Julie is going to require, or our state is going to require 48 hours. Eventually, a lot of states will probably have 72. They are digging at a record amount across our state. And 1 million calls into Illinois through the one call system. And I mean one call means you make a call to the Julie group or the 811 group. They call the utility, the gas company, and instead of you trying to call 12 people, they call everybody that might be involved. The spoil pile or excavated earth, spoil is a term we use out here in the Midwest, has got to be 2 feet away, as shown over in the right. First question I'm looking at, where's our ladder? How deep is it? These are questions that you have to look at as a competent person or doing a safety audit. Hazardous atmospheres have to be checked at least 4 feet when oxygen deficiency or hazardous could exist. So anything with a live sewer main, you could have toxic gases of methane, hydrogen sulfide, other equipment. You're going to run a generator, you have carbon monoxide hazards. You have gasoline can, you have a gasoline vapor. People have a lot of times hard time thinking, I'm up 8 feet, it's 7 feet wide, why do I need it? It's got air up to the top. But remember, all the hydrocarbons generally go down low. All the solvents go down low. So you'll be at the point of danger. Methane rises up, goes to the air, but you get a lot of methane, you can have an explosion. I'll give you an example of a death out in Houston or Dallas. They were out there. You would have checked the air. They got a nice protective system, ladders 3 feet above the landing, but they hit the live sewer main and the gases. If you had a meter in that trench, you would have picked up, wow, this is toxic gases starting to seep out. Everybody get out. Everybody get out. We're going to have ventilation systems blow and clean this air out. We got to try to block the sewer. That may require an SCBA or something. You got to have it safe to go back in there. But if you don't think of the hazards. Hydrogen sulfide smells like rotten eggs, and that can kill you with a few breaths if you get enough of it in. So that's why you have to think about maybe taking a meter on these live sewer mains. So the knowledge check for soil classifications: A, B, C, or D. A, B, C, or solid rock. A60, A20, B, C, or ABC Waterlogged C. Excellent job. It is indeed ABC in solid rock. Water makes it weak. Remember, if you just take a chunk of dirt and put it in a bowl, you start pushing around it, it's going to start dissolving that dirt. That's what it does to the soil. It makes the soil underneath it so bad, in this case, it just cracks off. So you got to pump it out. That's one of the things, competent person. You know, a lot of the area, this month in October here, we have a lot of rain. So every day you're checking for the water in the trench because it's going to make it from an A to a C or B to a C. The ladder, 3 foot above the landing, is a number 2 most cited OSHA violation of all. And I was dealing with a contractor this week that didn't have the ladder 3 feet at it, right at the edge, didn't have the dirt pushed 2 feet back, and then they had the box too low. They cited $8,000 for the ladder. That's an $8,000 ladder. 1 mile, 1 kilometer away, they had 50 ladders in their machine barn, and you could have gone into the shop and got a longer ladder. This whole crew knows it. They've been trained. That's tough for a company to accept. You've done training. You're going to have to sit down with this crew and talk about these items are what we expect. But in the audits, they weren't doing it. They weren't doing it every crew every month. And they've got to change that because you will find this out. This just didn't happen the first time. I'm sure it's happened multiple times. But if you said, I haven't audited this crew but once a year, who knows what they're doing the rest of the summer and stuff. You need to get it out there. You'll find these crews that are not doing it right. Here we are. We got a nice sheeted system. This is going to be designed by an engineer. You know, they're going to develop the bracing. We got our ladder. We're going to do underground boring. Pretty good system. Spoil piles must be excavated how many feet away? 1, 2, 3, or 4. Excellent. It is 2 feet. I show a lot of good pictures. When I do audits, they should be 98% right. Everything is done right. I got my ladder. I got the spoil pile away. We got our cave-in protection. Excellent. I like to show the good because if you got a good program and a good company, you should see nothing but good. Show the workers in your company doing it right. That makes a big difference. Some people, they don't care. They have no fear. He's in a trench 13.5 feet deep. It's supposed to be A soil. You would cut this back 3/4 of 1, or about 9 feet. That means 9 feet cut back of all this dirt, 9 feet cut back off this dirt. You got spoiled dirt at the edge, no cave-in protection, no ladder, no hard hat, no safety glasses, and so on. That's no good. Swing radius means this counterweight can kill you. If it hits you, it's going to knock you down. If you get caught between this and the track, it could kill you. So another scenario-based question. You're the safety professional conducting an audit for one of the crews for safety compliance with the company's program. That's why you do audits. You want to make sure that they're following what you think they're supposed to do. The professional spots the worker in a 13-foot deep trench with vertical walls, kind of like our picture before. It is 5 feet wide. The soil appears to be A or B. What should be your first action? Offer the workers a excavation safety class. Ask to see the job hazard analysis. Conduct the soil analysis to classify the soil. Have the employees exit the trench immediately. Excellent. This is going to kill him. When we go back to this trench, that can cave in and kill him instantly. You got to get him out. Got to talk about it and talk to the crew. What's going on? Why aren't we not doing this? We have everything there to do it right. It makes me upset when I see all the protective systems sitting there by the trench and they're not using it. That's a tough management situation because the boss has to make a decision. Why is this foreman, my crew, not using what they got to use? They got it right there. So when we talk about collapses, this case, it's an 8-foot deep on the left side, 15-foot high on the other side, and the chunk hits this guy in the ribs and breaks 4 ribs. It's lucky it didn't kill him and collapse this whole thing. The 15-foot stood up in the middle of the winter. So we're going to test the soil after they get him out of the trench. We have cohesive soil. I can put my thumb in it. OSHA actually recognizes that your thumb testing. It stays together, it's cohesive, it's got some clay in it. B soil. If I had A soil, I couldn't even put my finger in it. It's hard as a rock almost. C soil, I can just squish it. It's usually sand, it just squishes apart, no cohesive at all. A ladder shall be within how many feet when placed in the trench? 10, 15, 20, 25. Everybody knows this one by heart. 25 is the right answer. So here we are. We got a ladder in the trench. That's good. Trench boxes must extend 18 inches above the grade or bank. So what we're talking about, they had the trench box too low. Not this company, but this is what it kind of was like. OSHA is going to require you to go down 18 inches, or approximately here, and then do the 1-to-1 if it's a B soil. You know, you put your slope at the thing. You wouldn't start from the top of the box. You wouldn't start from here. You go down 18 inches. The idea is that 18-inch lip is going to prevent anything from rolling in. Knowledge check. This is hard. 1 out of 10 people can get this because it is a math question. The CHST questions, sometimes this is called math. It's tough as they get. Trench is 4 feet wide at the bottom, 8 feet high on the vertical walls. We classify the soil type as B. What would the top width be if we're going to use pure sloping as a method of protection? 6 feet, 8 feet, 10 feet, 20. Okay, it is 20 feet. Should be red. 20 feet. We have 4 feet wide at the bottom, 8 feet high. From here to here, 8 feet. From here to here is 8 feet. We have to do it a 1-to-1. We have to cut out all this dirt 8 feet. We cut out all this dirt 8 feet. So when we measure from here to the vertical of this toe, it's going to be 8 feet plus 4 feet plus 8 feet is 20 feet is your answer. So there it is, 20 feet. Soil cracking due to vibration from traffic. Soil type was classified as C. If you can feel the vibrations or see cracks, like these cracks, it's going to go from an A to a B, B to a C. The rules are that we teach in OSHA, you got to feel the vibration. Good analogies, if you watch a train pass and you're like 4 meters or 15, 20 feet away, you'll feel that train vibration in your legs. Power lines kill everybody once a week. 1 person dies a week, 50 a year. You name it, it hits it. Excavators hit it too. These Caterpillar excavators can get up 10 meters, 33 feet up in the air, and get right on these insulated power lines, 7,000 volts. That's the violation. This is within 5 feet of it because it's past the cable TV. Cable TV is usually about 10 feet below. Excavator here extends 42 inches. If I pull it out and measure it, that can hit you. I've had people get hit with it, break their chest bone, and fall to the ground. They can't even get up because they can't breathe because the chest bone is broken, and that's a painful injury. We've had people climb up over here to go talk to the operator, and then this thing pivots and they kill them. Crushes them between the top of this and the top of the track. So we tell people, cone it off, do something. Have a program in place so you're going to tell, okay, I need to talk to this operator. I've got to give him a stop signal. He's got to kill the engine, then I can approach him. You know, don't be assumed that he sees you because that happens in the death cases. They don't see him. The operator says, I didn't even see the person. And it can be done. You know, all the guardrails can be put on. All the companies who rent it or sell it, they have these guardrail systems, and that's what you want to have. Type B soil, this should be easy by now. Sloped at what? 1/2 to 1, 3/4 to 1, 1 to 1, 1.5 to 1. Very easy. Everybody knows this. 1 to 1. Many contractors don't put in end protection. One of the things about these trench boxes, you have an open end. You can use 1-inch steel plate for 8-10 feet easy. You know, if you take B soil, you take a 20-foot plate, push 10 foot of it in, 10 foot stick out, that'll be fine. But when you get over 20 feet, remember, you're going to have a hole engineered anyway. So in my years, I've never seen steel plate buckle under 20 feet. You know, it's usually pretty good. I mean, obviously, you have to have somebody look at this issue. It's supposed to be some data behind it. But you want that end protection, because I see a lot of cave-ins every year with the ends, comes at the ends. They got the sides protected, but you got to remember all four sides can be cave-in potentials. Any questions? All right, I want to thank everybody for coming. Hope to do this again every month. As I said, we're on the BCSP Facebook group. We have about 4,800 members. We have 1,500 questions or so. Again, we don't take the original questions. We don't take and post exam core or other proprietary questions. We would just rewrite the question to focus on the principle of the question. Thank you very much, and I'll see you next month.